Zero Shadow Day observed in Bangalore. The event was held at the premises of Indian Institute of Astrophysics that was attended by student community from Chennai who had live experience with expertise in Bhopal with calculated approach with book precision to obtain desired results in Bangalore in a live event at the IIA auditorium. It may be noted that the Zero Shadow Day is observed on April 24th and August 18th each year in Bangalore. Normally, it has clear visibility in April, while in August it is overshadowed due to monsoon in Bangalore. BTech student community from Chennai were seen calculating with Bhopal-based Aryabhatta Foundation in obtaining precise figures, portraying perfect calculations, which gave them exposure to India's scientific community. On the occasion, retired Indian Institute of Astrophysics scientist Dr. R.C. Kapoor also interacted with the student community. The purpose to accommodate large section of student community is to encourage them to take a post-graduation, internship and PhD going by the technical studies with which India is progressing. There was outdoor event spread across in the IIA lawns in which instruments were placed to witness live Zero Shadow Day today. It was here exactly at 12:17. With the help of various instruments, zero effect was demonstrated in which sunlight was exactly zeroed, in which the sunlight penetrated directly atop demonstrating zero shadow effect. The event was conducted under supervision of Dr. Neeraj Mohan Ramanujam, who is the head of outreach section of IIA, Science, Communication, Public Outreach and Education section. The Indian Institute of Astrophysics collaborated with Bhopal-based NGO Aryabhatta Foundation in obtaining precise measurements with 100% precision on the occasion of Zero Shadow Day in Bangalore.
So Zero Shadow Day was observed today in Bangalore here at IIA. What do you have to say about this, sir?
This is a very interesting event, and this happens twice a year. For example, in Bangalore, it is on 24th April, and then also on a day in August. And this happens any place which is between the Tropic of Cancer and Tropic of Capricorn. So a large number of states in India are covered in this, and this happens because the axis of the Earth is inclined to its orbit by about 23.5 degrees, and at this particular moment, as we have seen, the shadow almost vanishing. That happened at 12:17, and at that time the sun is just overhead, and that moment has already passed, and again our shadow starts showing up. And in the images you will see how the shadow has disappeared in the various experiments here. Also you have noticed the way the shadow gradually disappears and then starts appearing again. So it's a very interesting event, and we can see around a very large number of school and college students and very young children also who are very curious and they want to know about certain things. This is one of the very simplest happenings that we notice, and the next is due in August, so let's hope we will be able to witness once again the same event.
Now you can put a mark. 12.
Yeah, 12 is one can put mark here.
From where? we have aligned them locally, and then we are just making it upward, looking up. So exactly at the zero shadow time, the light going from first hole will go through this first hole, and then it will fall here. So you'll found IIA light dots here. So you see these light dots. So suddenly IIA will start appearing. At the same time, these three sensors are receiving light coming from these plates. So we are blocking one of the hole on each of this IIA, and then we are measuring the light intensity coming on them, and then seeing if it is equal and beyond certain threshold. And that threshold is adjusted for the light which is expected at the time of zero shadow.
So what is done? You can tell them what you did.
So as I said, like the light will pass through all three holes and it is forming this IA logo. At the same time, after the second plate, we have put three detectors in each of this letter. So if all three detectors are getting equal light and beyond certain three, once the light passes on the sensor, it will stop automatically. So just to indicate that now is the time when you should look at the zero shadow. And also try to see your own shadow, because that is also the easiest experiment which you can do. Your own shadow will disappear.
Exactly at the
Yeah, and write the time 11:40.
11:41.
Yeah, no, 11:40 is okay. Radian, okay. Beneath this line, yeah. 11:40 a.m. a.m. Okay. Every somewhere in Nile, that particular time of the year, you don't see any shadow for the well. So there was a well, and when people look down, there's no shadow. So he heard about this. Then he thought, let's do an experiment. So he kept a stick at that place and another stick at Alexandria. Okay. So what he asked, go over there on that specific day, go observe it, and then start walking. So he paid our guy to walk the entire length of Alexandria, basically measuring each and everything.
Then you'll hear a buzzer.
See, this is slowly concentrate.
What is this basically showing?
So there are three plates, and all the holes on these plates are aligned, and these plates are perpendicular to the incoming light. So exactly at the zero shadow time, all the rays coming from sun will pass through all three holes and form nice circles, and it will form a IA logo kind of thing. And
Basically, do you know the story how we measured the radius of the sun, Earth? Okay. So Aristonychus, he kind of heard a news that somewhere in southern Nile that there is a well. It doesn't cast any shadow. Okay. So he heard about that. He asked the guy to go over there in southern Nile, and he said on exact day you observe that. Okay, on exact day. At the same
You are here at IIA to witness Zero Shadow Day. What did you like the most here?
So I saw a lot of experiments, and my favorite was when they had put a large iron or metal stick, and then around it there were few circles, and every 5 minutes the sun would come more closer to us. So every 5 minutes the shadow would become smaller and smaller, so we would mark it. That was one of my favorite activities. I marked it like twice. And also the other activity was where there were 3 layers and they had holes. One was like the holes were a bit bigger and the placement was closer, so the light when the sun was just above it, the light would pass through easily and the art would be shown. But there was one where the hole was smaller and the distance was much more, like this was the distance between the 2 layers. So in that one it took a bit time, and it came at exactly 12:17, and I really liked all the activities. And even our shadow, we could only see it just below ourselves, not like how we normally see it.
Where does the sun set? West. Does it rise exactly at east every day? Why? What does it do? All questions I asked, the answer is in the slide only. You can read the slide and tell me, or you can tell me yourself. How hands up for the second question? Why do you think it doesn't rise in the east or sets in the west exactly? Photographs added together taken by this guy in Pune, okay, some few years ago. So he just photographed the same view out of his window at sunset, and then he looked at, see, sun is setting here on 15th March, here on 19th April, here on 10th May, here on 7th June. What are you noticing? Sunset is not exactly at one point, it's changing. From March to June, it's moved so much, right? Now let's look at this picture taken from, by this person from Finland, okay? Again, same view, every month he saw. So this is December, January, February, March, April, May, June, July, August, September, November. Here it says December solstice, March equinox, June solstice, September equinox. And this is sunrise. What do you see here?